This question is from GATE 2013 Mechanical Engineering paper, question number 39. A single degree of freedom system having mass 1 kg and stiffness 10 kN per meter initially at rest is subjected to an impulse force of magnitude 5 kN for 10 to the power minus 4 seconds. The amplitude in millimeter of the resulting free vibration is dash. Let's write the given information first. So it's given that mass is 1 kg. It's a single degree of freedom system. A single mass is given. A single spring is also given. Stiffness of the system is 10 kN per meter. It is subjected to an impulse force of magnitude 5 kN. So we can write force, external force is 5 kN. And the time for which it is subjected is 10 to the power minus 4 seconds. And we need to find out amplitude or response x in millimeters of the resulting free vibration. So it's a free vibration, it is not a force vibration. This is an initial impulse force for a very less time. So let's see how it will be calculated. Now in this single degree of freedom system, in order to calculate x, we need to use an equation in which x will be mentioned. So we can use energy equation here, that is the total energy of the system should be conserved. So we can write by energy balance half mv square, which is nothing but the kinetic energy of the mass, will be equal to half k x square, where x is the elongation of spring, which is nothing but response of the system, and this is the potential energy stored in the spring. So kinetic energy of the mass will be stored in the spring as potential energy, and that is why we are equating the two. Now from here we can find out x as root over mv square upon k. But we don't know the velocity of the mass here. We only know the mass and the stiffness. So this velocity of mass can be found out using the impulse force and the time for which the force applied is given. So using these two we can find out velocity by impulse momentum theorem. Because when the impulse force is applied, how is the energy transferred? By changing the momentum of the system. Impulse F into t will be equal to change in momentum. Let the initial velocity be u and final be v. So we have m into v is the final momentum minus initial momentum is m into u. Initial velocity of the system can be taken as 0 because it was at rest. It's given that initially the system was at rest. So let's substitute the values here. Force is 5 kN, time is 10 to the power minus 4 seconds. And this kilonewton to be converted to Newton, we have into 10 to the power 3 is equal to, mass can be taken common. So we have mass is given as 1 kg into, we don't know the final velocity, minus the initial velocity is 0. So it is simply v equal to 0.5 meter per second. Now this is the final velocity of the mass. Response of the system will be calculated using this formula. Although 0.5 is given in the option, don't jump to the conclusion and go and mark 0.5 as answer. So still we need to find out the response. It is x equal to under root, mass is 1 kg, velocity we found out 0.5 square of it, divided by stiffness of the system is given to be 10 kN per meter. So it is 10 into 10 to the power 3 Newton per meter. X will be equal to root over 0.5 square is nothing but 0.5. So 0.5 into 1 upon 10 to the power 4 becomes 10 to the power minus 4 and its square root is 10 to the power minus 2. But this answer is in meter. So when to convert in millimeters, in which the options are given, we have x is equal to 0.5 into 10 to the power minus 2 into 10 to the power 3. 0.5 into 10, which is 5 in millimeters. Let's go back and mark the correct option. So the answer is in option C, that is 5 millimeters. For further details on this topic, you can refer to the NPTEL video, Module 11, Lecture 29, Impulse and Momentum, from the course Lecture Series on Engineering Mechanics. This course is by Professor U.S. Dikshit. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.